गजाननं भूतगणादिसेवितं कपित्थजम्बूफलचारुभक्षणम् उमासुतं शोकविनाशकारकं नमामि विघ्नेश्वर पादपङ्कजम् वर्णानामर्थसङ्गानां रसानां छन्दसामपि मङ्गलानां च कर्तारो वन्दे वाणी विनायको। नमस्कार, मैं आप सभी का स्वागत करता हूँ। आज की इस वीडियो के साथ जुड़ने से पहले मैंने अपने इष्ट देव की पूजा की। मैं यहाँ पर मात्र एक संकेत देना चाहता हूँ कि जब भी हम अपने किसी भी नए कार्य को शुरू करें, हमें अपने इष्ट देव की पूजा अर्चना जरूर करनी चाहिए, उन्हें याद जरूर करना चाहिए। हम किसी भी धर्म से संबंधित हो सकते हैं। किसी भी दूसरे धर्म की आलोचना करना अच्छी बात नहीं है। सभी धर्मों को एक मानते हुए हमें अपने जीवन में मानवता धर्म को सर्वोपरि स्थान देना चाहिए। विद्वान लोगों की संगति में रहना चाहिए और हर रोज़ कोई ना कोई नई चीज़ जरूर सीखनी चाहिए। तो शुरू करते हैं आज का वीडियो। आज हम डिस्कस करने जा रहे हैं एलिप्स, conic section. The name of the chapter is conic section. So let us proceed now. The questions of the exercise as well as the introductory part of the topic ellipse. Class 11, subject mathematics. Chapter is conic sections and the topic of the day is ellipse. Today we are going to discuss about ellipse. So first of all, the introduction. What is the ellipse? The definition says an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in a plane is a constant. So what is the meaning of this? Now to explain the definition, let us have the geometrical interpretation. Suppose we have this shape, okay, and this is one point, say f1, and this is second point, say f2. These are the two fixed points, f1 and f2. These are two fixed points. Now what is the thing? P is the moving point. Suppose this is P1. First time this is P1. Now distance from F2 to F1, F2 P1, then P1 to F1. Okay, we write here P1 F1 distance plus P1 F2 this distance. Okay, second time the moving point P1 reaches here, so this becomes P2. Now what we say, P2 to F2 and this distance, this equal to, we say here, from P2 to F1 plus from P2 the distance up to F2. So these two distances are same. Third time, if this moving point reaches here, suppose the position is here P3. Now the distance is, sum of the distances, this is equal to, from P3 up to F1, the distance, plus from P3 the distance F2. So these distances, they remains constant, suppose they are equal to K. So this is what the definition is saying about ellipse. If we want to know more about the ellipse, then suppose this is the system of coordinate axes, x-axis and y-axis. Here we are going to describe the ellipse like this. This is the shape of the ellipse. Now one thing is here, this point from O to this point, suppose this is A and this distance is A distance, right? The same distance is here, this distance is also A distance. So coordinates of A are A comma 0, and here this is A dash, image of A, that is minus A comma 0, and here suppose this distance is B unit, so we write here this point as B, 0 comma B, the coordinates are 0 comma B, and this point is, this distance is also same, and this is the image of B, so B dash, 0 comma minus B are the coordinates of B dash, right? Now two fixed points we take from here to, suppose here we have focus F1, same distance to the right side, and the line parallel to y-axis through this point, we take this line is called directrix. Similarly, the second same distance here, this is the second point, fixed point F2, to the left side same distance we take here, from through this parallel to y-axis we have the second line, this is also fixed line, this is the second directrix of the ellipse. So these two lines, this is the directrix of the ellipse, this line is also the directrix of the ellipse. This point is called vertex, and this is also called vertex. So what we say, vertices, when we discuss about the ellipse we discuss about vertices, because there are two vertices of the ellipse. These 2 points are not the vertices, because the length of major axis, this major axis, this distance is 2a, this is called major axis. So about this major axis, these 2 points are called vertices. Okay, so this way we have the first ellipse. Equation of this ellipse is written this way. What is the ellipse equation? X square upon a square plus y square upon b square is equal to 1. Okay, here the important thing is a is greater than b. This is very important in case of ellipse. Okay, now we shall discuss about 2 kinds of ellipses through the table, like we have discussed in case of parabola. There were 4 parabolas, 4 types of parabolas. Here we are going to discuss 2 types of ellipses. We shall discuss these two ellipses in this table. First of all, shape of the ellipse. This is the first kind. Okay, x-axis and y-axis. So this is the first kind, and second kind we have this type. Again we have y-axis and x-axis, right? Now we discuss about equation. In first case, this is the vertex A, second vertex A dash. So this distance is A. So we write here x square upon A square plus y square upon B square is equal to 1. This point is B dash. Okay, A distance A0 minus A comma 0. Likewise, here we have y square upon A square plus x square upon B square is equal to 1 is the equation of this ellipse. Here this point is A point and this point is A dash. The coordinates of A are 0 comma A and here coordinates are 0 comma minus A, and this is point B. This is point B dash. Okay, coordinates are B comma 0. Here coordinates are minus B comma 0. Right? Next one is vertices. Here in this case, the vertices are plus minus A comma 0. In second type, the vertices are 0 comma plus minus A. Only these 2 points are called vertices. Okay. Measure axis A to A dash. A to A dash. This distance is called measure axis, length of measure axis. So this is about, in first case, measure axes are about x-axis, and in this type the measure axes are about y-axis. Okay, next is now focus. We know that fixed points are called focus. One focus point, second. So plural form of focus, foci, f1, f2. Here in this case we have f1 is this and this is f2. So we write here foci, the plural form of foci. So if the coordinates of focus, we consider this as plus minus c comma 0, and here in this case the coordinates of focus are foci are 0 comma plus minus c. Okay, now what is this c? C is equal to AE. Here also C is equal to AE. E is called eccentricity. Eccentricity means the directrix. This is the directrix. Okay. From focus, this is the point P, any moving point on the ellipse. The distance, the ratio of the distance is P1 to F1, and this is the perpendicular. PF1 divide PM. This ratio is called E, eccentricity. We can also define this C as C square is equal to A square minus B square. Here also the value of C square is obtained from this relation, C square equal to A square minus B square. Next we have latus rectum, length of latus rectum. So first of all, what is the latus rectum? Latus rectum means through focus parallel to the directrix, the line. This distance is called length of latus rectum. So this distance is called, two lengths are there latus rectum. So length of latus rectum in first case this is 2b square upon a. In second case also we have the same, 2b square upon a is the length of latus rectum. So this is what about the ellipse. Through this table we have explained everything of the ellipse, and on the basis of this table we can solve each and every question related to the exercise ellipse, exercise 11.3. So let us start now the question. The very first question of the exercise is, find the coordinates of the foci, the vertices, the length of the major axis, the minor axis, the eccentricity, and the length of the latus rectum of the ellipse. X square upon 36 plus y square upon 16 is equal to 1. So first of all, what we see here, 36 is greater than 16. And in case of ellipse we say a is greater than b. So a square is also greater than b square. So 36 is a square. A square is equal to 36 and b square is equal to 16. From here we can say the value of a is 6 and that of b is 4. Right? Now the condition is c square is equal to a square minus b square. So we substitute the values, 36 minus 16, that is equal to 20. That means c is equal to square root of 20, which is equal to 2 into square root of 5. Right? Now we can find the desired number 1. What is foci? Foci we say plus minus c comma 0. So this becomes plus minus c is 2 square root of 5 comma 0. Second one, what is the question? The vertices. Vertices here we have plus minus a comma 0. So this becomes plus minus a is 6, 0. Third thing is the length of the major axis. The length of the major axis, that is equal to 2 times into a, which is equal to 2 into a is 6 is equal to 12. Next is number 4, the length of the minor axis, and that is equal to 2b. 2 into the value of b is 4, so this is equal to 8. Next, the eccentricity. Here eccentricity is e, and we know that E is equal to C upon A. A upon C, because we know that C is equal to AE. So this concludes E is equal to C upon A. That is, eccentricity is equal to 2 square root 5 divide A. A is 6. So this becomes square root 5 upon 3. Our next part is the length of latus rectum. The length of latus rectum, this is equal to 2b square upon A. So here we have 2 into b square is 16 upon A. A is 6. So this becomes 16 upon 3. So this way all the parts they are solved. Now similarly we can solve other questions. Question number 2 is find the coordinates of the foci, the length, the vertices, the length of the major axis, the minor axis, the eccentricity, and the length of the latus rectum of the ellipse x square upon 4 plus y square upon 25 is equal to 1. So what we see here, this is of the form y square upon a square plus x square upon b square is equal to 1, because we know that a square is always greater than b square in case of ellipse. 25 is greater than 4. So a square is equal to 25. That means the value of a is 5. Okay. B square is equal to 4. So we have b is equal to 2. From here we can find c square is equal to a square minus b square, which is equal to 25 minus 4 equal to 21. So c is equal to plus minus square root of 21. Right? So this way, now proceeding towards the question, what are foci? Foci in this case will be equal to 0 comma plus minus c. So this becomes 0 plus minus the value of c is square root of 21. Second part, vertices, they are 0 comma plus minus a, that is 0 comma plus minus what is a, this is 5. Length of the major axis is 2a, and here 2 into the value of a is 5. This becomes equal to 10. The length of the minor axis is equal to 2b. So here we have 2 into b is 2 equal to 4. Next, eccentricity. We know that E is equal to C upon A. Okay. So this becomes, what is C? Square root 21 upon A is 5. Lastly, we have the length of latus rectum. So this is 2b square upon A equal to 2 into b square is 4 upon A is 5 equal to 8 upon 5. Now next part, next question. Question number 3. Find the coordinates of the foci the vertices, the length of the major axis, the minor axis, the eccentricity, and the length of the lattice rectum of the ellipse. X square upon 16 plus y square upon 9 is equal to 1. Again we see that this is a square. A square is 16 and b square is 9. So a is equal to 4, b is equal to 3. Mean to say we have the equation of the form x square upon a square plus y square upon b square is equal to 1. Now we can say what is c square? This is equal to a square minus b square. Substituting the value, this is equal to 16 minus 9. So this is equal to 7. Right? Mean to say c is equal to square root of 7. Now what are the foci? Foci. In this case we have plus minus c comma 0. This becomes plus minus c is 7 comma 0. What this is? Plus minus a comma 0. That is, this is equal to plus minus 4 comma 0. Length of the major axis, this is 2a. That is equal to 2 into 4 equal to 8. The length of the minor axis 2b, that is 2 into 3 equal to 6. Next is the eccentricity. E is equal to c upon a, which is equal to square root of 7 divide 4. Last one is the length of the lattice rectum, which is equal to 2b square upon a, that is 2 into 9 upon 4, that is 9 upon 2. Next question. In question number 4 we have the equation of the ellipse is x square upon 25 plus y square upon 100 equal to 1. So here 100 is greater than 25. Greater one is called a square is equal to 100. B square is equal to 25. So we say a is equal to 10 and b is equal to 5. From this we can find c square equal to a square minus b square, that is 100 minus 25, which is equal to 75. So the value of c is square root of 75, which is equal to 5 into square root of 3. Right? Now foci. This equation is of the form y square upon a square plus x square upon b square is equal to 1. So what are the foci in this case? 0 comma plus minus c, which becomes 0 comma plus minus 5 square root of 3. What are the vertices? 0 comma plus minus a, that is 0 comma plus minus 10. The length of the major axis 2a, which becomes 2 into 10, 20. Length of minor axis 2b, that is 2 into 5, 10. The eccentricity E is equal to c upon a, which is equal to 5 square root of 3. A is 10. So this becomes square root 3 upon 2. Last one is the length of the lattice rectum, which is 2b square upon a, equal to 2 into 25 upon a is 10. So this means 2, 5, 5, 5s are. So we have 5 as the length of lattice rectum. Now next question. Question number 5. Here the equation of the ellipse is x square upon 49 plus y square upon 36 is equal to 1. So here what we see, 49 is greater than 36. So a square is 49. That means a is equal to 7 and b square is 36. So that means b is equal to 6. So this equation is of the form x square upon a square plus y square upon b square is equal to 1. First type. Also we can find c square, which is equal to a square minus b square. So substituting the values, 49 minus 36, this is equal to 13, right? So c is equal to square root of 13. Now what are the foci? They are, according to this, plus minus c comma 0, which is equal to plus minus c is square root of 13 comma 0. What are the vertices? They are plus minus a comma 0, that is plus minus, what is a? 7 comma 0. The length of the major x is 2a, 2 into 7, 14. The length of minor x is 2b, equal to 2 into 6, 12. Eccentricity, E is equal to c upon a is equal to square root 13 divide 7. And last one is the length of lattice rectum, 2b square upon a equal to 2 into 36 divide 7, which is equal to 72 upon 7. Now next question. Question number 6. X square upon 100 plus y square upon 400 equal to 1. So 400 is a square because this is greater. A square is 400. So a is equal to 20. And this is b square is equal to 100. That is b is equal to 10. Now we can find c square equal to a square minus b square. 400 minus 100. So this is 300. So value of c is 10 square root of 3. Right? Now what we have? We have the equation x square upon y square upon a square plus x square upon b square is equal to 1. So from this equation we know what are the coordinates of the foci. They are 0 comma plus minus c. This becomes 0 comma plus minus 10 square root of 3. Vertices, they are 0 comma plus minus a. So this becomes 0 comma plus minus 20. Length of major x is 2a, that is 2 into 20, 40. Length of minor x is 2b, that is 2 into 10, 20. Eccentricity c upon a, that is 10 square root of 3 upon 20, which becomes square root 3 upon 2. Next is the length of lattice rectum, 2b square upon a 2 into 100 divide 20. So this is 5 into 2, 10. Now next question. Question number 7. Ellipse is 36x square plus 4y square is equal to 144. So what we know about the ellipse? Right hand side should be equal to 1. So dividing throughout by 144, this becomes 36 upon 144 x square plus 4y square upon 144 is equal to 1. So from here we have x square upon 4 plus y square upon 36 is equal to 1. So from this, because this is a square, that is a is equal to 6. Likewise, this is b square. So b is equal to 2. Now we can say c square is equal to a square minus b square. That is 36 minus 4 equal to 32. Right? So what is c? c is equal to 4 square root of 2. Okay, now coming to foci, y square upon a square is the form of the ellipse. Foci is 0 comma plus minus c. So this is equal to 0 comma plus minus c is 4 square root of 2. Vertex is 0 comma plus minus a, that is 0 comma plus minus, what is a? A is equal to 6. Length of major x is 2a, so 6 into 2, 12. Length of minor x is 2b, so 2 into 2, 4. Eccentricity E is equal to c upon a. What is c? This is 4 square root of 2 upon a is 6. So this becomes 2 square root of 2 upon 3. And lastly we have the length of latus rectum. Formula is 2b square upon a. So this is 2 into 4 upon 6. So this becomes 4 upon 3 is the length of latus rectum. Now next question. Question number 8. The equation of the ellipse is 16x square plus y square is equal to 16. Again we need right hand side should be equal to 1. So dividing throughout by 16, we have x square upon 1 plus y square upon 16 is equal to 1. That means greater one is called a square and this is the b square. So from here we can say b is 1 and from here we can say a is 4. So we have the value of c square is equal to a square minus b square. 16 minus 1 equal to 15. So c is equal to square root of 15. Now what are the foci? Y square upon a square form. So we have 0 comma plus minus c, that is 0 comma plus minus square root 15. Vertex is 0 comma plus minus a, that is 0 comma plus minus a is 4. Length of major x is 2a equal to 8. Length of minor x is 2b equal to 2. Eccentricity c is equal to e is equal to c upon a, square root 15 upon 4. And lastly the length of latus rectum, 2b square upon a. 2 into 1 upon a is 4. So 1 upon 2 is the length of lattice rectum. Next question. In question number 9, the equation of the ellipse is 4x square plus 9y square is equal to 36. So we need right hand side should be equal to 1, dividing both sides by 36. So we have 4x square upon 36 plus 9y square upon 36 is equal to 1. That is x square upon 9 plus y square upon 4 is equal to 1. So this is of the form x square upon a square plus y square upon b square is equal to 1. So from here we say a square is 9 and b square is 4. So what we say, a is 3 and b is 4, 2. That means c square is equal to a square minus b square. That is 9 minus 4, which is equal to 5. So from here we can conclude the value of c, which is square root of 5. Now x square upon a square plus y square upon b square is the form. So foci will be plus minus c comma 0, which becomes plus minus square root of 5 comma 0. Vertices are plus minus a comma 0, that is equal to plus minus 3 comma 0. Length of major axis 2a is equal to 2 into 3, 6. Length of minor axis 2b, which is equal to 2 into b is 2, 4. Eccentricity E is equal to c upon a. So square root of 5 upon a is 3. Length of lattice rectum 2b square upon a. 2 into 4 upon a is 3. 8 upon 3 is the length